So good afternoon. My name is Seth Hornstein, and as the Undergraduate Associate Chair for the Department of Astrophysical and Planetary Sciences, I'd like to welcome you all to the commencement ceremony for the graduating class of spring 2023. First, one housekeeping announcement. Before we get going, for those of you who aren't familiar with our amazing planetarium, the emergency exits are the door you came in and on the opposite side of the theater. But just one word of warning, if you go rushing out of here in a panic for some reason, don't head straight towards the exit sign. They are over a wall. So take one step to the right. But not two, because there's a post in the way. Just one. But seriously, to our graduates, you've completed a rigorous course of study in our department. Hopefully, you have grown as scholars, scientists, and more broadly, as humans. But before we give you your fake diplomas, you see, only the university has the power to actually grant degrees. I have one last real quiz for you. You've all brought your clickers, right? I guess we can do it the old-fashioned way. All right, raise your hand, graduates, if you have completed the planetary sequence, learning more about planets, moons, and rings than you ever thought possible. Okay. Completed the astrophysics sequence, which we lovingly refer to as Starfleet Academy. Decided you had such a thirst for astronomy or a glutton for punishment that you took both. Spent at least one late night in Summer Spouse Observatory, fighting with telescope issues, uncooperative weather, freezing observing room, and more telescope issues. Worked as an LA, grader, tutor, mentor, or all-around astro knowledge purveyor, only to realize you weren't even all that sure of it yourself. Came home on break to excitedly regale your family and friends about the latest astronomical tidbit you learned, or some upcoming astronomical event, saying things like, sure, it's freezing outside and it's 3 a.m., but you have to go outside to see the total lunar eclipse. Learned the ins and outs of the confusing labyrinth that is Dwayne physics, and figured out at 2 a.m. which doors were unlocked so you could get to where you needed to go. Did research with a faculty member, postdoc, grad student, or any other researcher, and learned that being an astronomer isn't standing outside and soaking up the wonder of the nighttime sky, but instead staring at your computer, trying to figure out what is wrong with your code. Anything else I've missed, or is that pretty much the experience? Again, seriously though, you've completed a truly cosmic journey. You've learned about everything from subatomic particles, created in the first instant of the universe, to the web of dark matter spread across billions of light years. You've embraced the discomfort of the unknown, realizing that the boundaries of human understanding are really only temporary. And in science, we seek to challenge hypotheses and are always open to resolving our ideas with new evidence. And perhaps the most important skill that you've gained is that you've learned how to think critically and scientifically, and you've learned how to approach difficult problems and how to learn on your own. Your skills prepare you to take on the world, whether it be in research, teaching, outreach, science policy, science journalism, or whatever your career path takes you into. Astronomy is an age-old human endeavor, a field that touches us all. From now on, when you tell people that you are an astronomer, you will see the wonder in their eyes as they ask you about the latest web image they saw and what it means. Because if nothing else, you now join the ranks of astronomy ambassadors, unleashed on the world. Do us proud and congratulations. I'd now like to introduce two of our current graduating class, Joe Zator and Eris Orion, two of our graduating students who will take us on a journey through time and space and tell us about the few things that they have been learning in their time here in APS.
Thank you, Seth, for that introduction. I'd also like to start by saying a quick thank you to Eris back in our navigation cockpit, as they have the monumental task of controlling everything that we see and hear during this live show while we're in the theater. And this is a live show that we will soon be flying through the universe And all of you here will get to experience the most important lesson that the graduates here have learned over the years through countless complex calculations, endless study in libraries, and so much coding, more than you could ever want. And that lesson is that space is really, really, really big. And while we're flying through, I do want to also note that you'll have plenty of opportunity to take plenty of photos throughout the day. So while we are having it dark in here, if you wouldn't mind keeping the flash photography to a minimum, or really none at all if you don't mind. And while we're flying as well, if you do at all become dizzied or disoriented, the best thing you could do is really to close your eyes and maybe put your head down, and your body should reset pretty quickly. So now I'd like to say a welcome to the distinguished faculty, to the family and friends of our students, and most importantly, to fellow graduates. It's your day, a day to celebrate and look back on what you've accomplished in these last few years. The changes that we've seen during our time here are only one link in the journey. Not just our individual journeys, but our collective journey as scientists and as curious humans. What's in store over the coming years is even more exciting. Not just because of what will come from amazing instruments like the James Webb Space Telescope, or the Mars 2020 rover Perseverance, or even upcoming amazing missions like the one to orbit Jupiter and study the Galilean moons, the Europa Clipper. Not just because of all that, but because each of your journeys as graduates will take you in directions that you cannot even imagine as you go forth from this special place. And I truly do believe that it's special here. This is actually my 4th graduation that I've been in over the past 20 years or so, and I can, without reservation, say that this is the only one of those graduations that has truly mattered to me. Even when I finished a master's degree back in Pennsylvania, I did not care about attending the ceremonies or any of the events. But here, CU Boulder is different. Here at Fisk Planetarium is different. And because of so many of you here today, the experience in the Astrophysical and Planetary Sciences department is different. This special couple of years together here is coming to a close, but it's only one step on everyone's journey. So on that note, let's take a quick journey all together through the cosmos to remind us of our place in the universe and why we have spent so many years studying its mysteries and its grandeur. We start here with our little blue marble, seeing it from the perspective that few humans have had the pleasure of seeing it from. But that is set to change as we head to the moon with the Artemis missions. Many graduates here will support that mission in many different ways, as humanity establishes a permanent presence on the moon and then heads towards Mars. Here we leave our pale blue dot behind, and soon leave our entire solar system. We can see here the path that the Voyager probes took, launched almost half a century ago and traveling at 35,000 miles per hour. You can get a sense of the scale as we start to leave our home system and enter a field of hundreds of billions of stars. I'll note too, everything that we see here on this flight that Eris is taking us on is real data from real observations made by fellow scientists. move further outside to see our galaxy, the halo of stars you see that are a little bit brightened there are the extent of what our human eyes can see. All the constellations are contained in that small sphere. And we eventually come to view our entire home galaxy, the Milky Way, stretching 100,000 light years across and bound together by dark matter with a supermassive black hole in the center. We begin to move to even more immense scales that are unimaginable. We start to see our local group of galaxies, and as we get to even grander scales, we'll start to see the Virgo supercluster, of which we are a part. And as we move further now, through the galaxies from the Tully survey, you can see that at this scale, each dot of light is actually an entire galaxy, containing perhaps hundreds of billions of stars and trillions of planets. We move further into the 2-mass data set, with slight colors representing the density of these galaxy clusters. We move billions of light years further, finally through the Sloan Digital Sky Survey galaxies in the QSO dataset, where we begin to see large-scale structures of the universe and the cosmic web. And we arrive here at the backdrop of the Planck scale CMB. And now, as we have gotten as far back as we can go, where we see this baby picture of the universe called the cosmic microwave background, an image of what would coalesce into everything we see in our universe. I'd like to leave you with the written words of Carl Sagan, as he provided a vision for the human future in space in his 1994 book. In this chapter, he describes how science is not just something we do, but a way to think about our world, a system to guide us on life's journey and move our collective civilization forward. He writes, "The significance of our lives on our fragile planet is then determined only by our own wisdom and courage. We are the custodians of life's meaning. We long for a parent to care for us, to forgive our errors, and to save us from childish mistakes. But knowledge is preferable to ignorance. Better by far to embrace the hard truth than a reassuring fable. If we crave some cosmic purpose, then let us find ourselves a worthy goal." So I invite you to keep looking up, and I'd like to say, once again, thank you and congratulations to all graduates.
Thank you, Eris and Joe. Hopefully now you can appreciate at least one little bit of everything that has gone into the last 4, 5, or 6 years of your child's graduation. I'd now like to call up another of our graduating students to speak a little bit about their experience. Molly Naring.
Hello, everyone. My name's Molly, and I just wanted to share a few words and thoughts about the value of prioritizing happiness over accomplishment. So I'm guessing that quite a few of us here grew up enjoying school and being pretty academically driven early on with our sense of personal value being at least somewhat tied to our academic performance. From a reasonably young age, I remember putting pressure on myself and pressure being put on me by teachers and just the education system and standardized testing to do really well in school. And it wasn't necessarily a bad thing, but when it's the only thing you hear, it instills a deeply rooted tie between accomplishment and self-worth. So when I got to college and failed my first exam, a lot of my self-esteem was washed away. But it was one of the most important experiences of my college career, and I think everyone deserves to fail an exam or do poorly in a class just because it's pretty sobering and sort of forces you to reframe how you think about yourself and deconstruct the way you value yourself. So college is hard, and it was really difficult for me to detach how much I was learning from the grades I was getting. Additionally, because this particular graduating class had their college experience dominated by the pandemic, I was really determined to do well, especially in the face of adversity, which eventually led to my downfall. So as we know, we had a uniquely turbulent and challenging college experience. We only got 2 spring breaks in college, which was devastating because I personally really feel like I missed out by not being able to trash beaches in Cabo and Miami every March. But at the heart of things, trying to complete a difficult degree while living through some pretty tragic and major historical events is very hard. When you spend every day worrying about the state of the world while also trying to do math and physics homework, it weighs on you. I lived alone in the dorms my sophomore year because there weren't enough people attending school in person to fill all of the dorms. And it was a rough time being by myself 24/7 and having to eat at the C4C outside in a tent in 20-degree weather. I now joke that one of the beds in my room was for sleeping and one was for crying. But it was my first experience really struggling with mental health, and even acknowledging that is a great privilege because I know most people struggle with poor psychological well-being at a younger age and live with it perpetually and typically for much bigger reasons than being locked in a dorm room. But regardless, I wasn't happy. I couldn't figure out why, and I thought it was just general stress due to school, but that didn't really explain why I felt like nothing mattered. I got selected for a really good internship that summer after my sophomore year, which I was excited about. And I accepted it, but it was going to be remote. And as the end of the semester grew closer, so did my feelings of existential dread and not knowing where my life was going. And I couldn't fathom spending another 4 months in my room alone. I was internally panicking because all I wanted to do was return to my previous summer job, which was working in an outdoor store in a mountain town. So it was like really fun, low key. But I felt like my future would be set back if I didn't do an internship. But because of my academic performance was my top priority and how I measured myself, it took me a really long time to realize that I'd probably end up worse for wear at the end of the summer and that it would set me back in ways a lot more permanent than foregoing 3 months of academic research would. I realized for the first time the importance of a work-life balance and how traditionally defined success can wait, but mental health can't. So that summer after sophomore year, I went back to that job at an outdoor store. I rejected the internship in the end, and I did a lot of work to reframe what really mattered in my life. And it's important to work hard. Doing well in school does matter, and trying your best does matter. And being academically successful is really good, but only if you detach your sense of self-worth from it. So in the long run, it's more important to take care of yourself and make sure you're living your life and doing fun things, not just checking off boxes. As we're graduating college with a degree that requires a tremendous amount of schoolwork, I hope you all learned that grades don't matter in the end, while learning does. And as long as you're working to learn the material in class rather than just get a good grade, you'll do fine. And really, school doesn't matter that much sometimes, while spending time with friends and doing fun things and things you enjoy always does. We very fortunately live in a society that values productivity and achievement more than anything else. And being very academically driven or career driven is really good and great and worthy of respect. but only if you balance that out with having other priorities in life. I didn't do an honors thesis or have stellar grades or do that much research during my time here, and I'm still walking across the stage with the rest of you. And many of us sitting here today grew up with dreams of being astronauts and explorers, and while that might not be what we want anymore, it's important to retain that desire to do something fun and interesting every day. So being the stereotypical Coloradan that I am, I make sure to spend a little bit of time every day either outside doing just fun things, so hiking, climbing, riding my bike. And each of us has our own hobbies, so going to a concert or on a trip with friends or having a movie night are all more valuable in the long term than finishing assignment or getting a bit of code to work. Prioritizing childlike play and making memories and leaving CU without thinking, gosh, I really wish I lived it up more in college is more important in the long term than the diplomas we hold. Because really people don't want to hear about your A in quantum mechanics. They want to hear about your party stories and about mountain biking and just fun things you did in college. The things that make life worth living are often the ones least tied to our success. So I hope all of you leave CU and go out into the world and enjoy yourself and enjoy the work you do and your hobbies and spending time with the people you care about, because being content in a well-rounded way is what really matters most. Last but not least, I want to say an enormous and sincere thank you to professors like Dave Brain and Zach Berta-Thompson for showing me that there are many paths you can follow in our field and helping me realize my passion for teaching. You both made my college experience a lot happier than it could have been, and that's something that I'll always be grateful for. I hope everyone graduating today feels fulfilled with their time here, and even if you don't know what your next steps are, you're right where you should be, and have everything to look forward to. So most importantly, make sure you make time to have fun and worry about achieving your goals another day. So as you go throughout life, no matter where you are or who you become, just make sure you sleep more than you study more than you party, and party as much as you possibly can. Thank you.
Thank you, Molly. I think it's always important to think about the priorities we have in life. And now, the moment we've all been waiting for, the presentation of the undergraduate degrees. I'd like to call up Professors Dave Brain and Steve Cranmer to help me with handing out these degrees.
Okay, thank you. So if you have an undergraduate receiving, I guess, fake bachelor's today, so we're going to pretend it's real, so I'm not going to use that word anymore. If you have an undergraduate receiving a bachelor's today, now is the time in the program that you've been waiting for. There are some instructions that go with this, both for your undergraduate and for the rest of you. First, for the undergraduates, I'm going to do this a little bit differently than I've done in the past. We're going to do it kind of row by row. You're already seated alphabetically from A to Z. So with just the first row of undergrads, please stand and line up on the wall from A back towards Z along the wall. The second row, you get to hang out for a bit. And then when you see one or two people left in the line, it's your time to stand up and join the line. Undergraduates, when your name is called, I will read your name and you will come up to the stage. Professors Cranmer and Hornstein will hand you your very real diploma, because that's now what it is. And you will stand here. And then there will be a picture taken. So the department will be taking pictures and posting pictures on the website. But parents will get to your instructions in a second. You're going to be welcome to come up and take pictures too. Undergraduates, understand the instructions? Yes, great. Everyone else, first, the controversial rule about applauding during graduation. Do it, please, loud and long for your undergraduate and for every undergraduate in the line. Got it? Good. Yeah, that's good practice. Nice. Excellent. Now we're warmed up. It should be easy from here on out. You are also welcome to come up and take a picture of your undergraduate. If you're trapped in the middle and like, please know that we're taking excellent pictures and we will be posting them. Okay, so without further ado, let's get this rolling. Oh, wait, no, there is one further ado. I will be also announcing graduation honors, and I want to describe a little bit what those have entailed. At some universities, graduation honors are simply a GPA designation. Here at CU, they are two things. Number one, they are a GPA designation. Number two, every student who is graduating with honors, either cum laude, magna cum laude, or summa cum laude, has completed an honors thesis. Sometimes that consists of 2 years of research, but usually more like 1 year of research, writing a paper, sometimes 20 to 50 pages, summarizing their research. They have defended that research to a panel of 3 professors in a talk. Sometimes it has other students or graduate students or postdocs in the room. Everyone but that panel of 3 professors has left the room, and then that student has been grilled by those professors about their research. And then the professors have made a recommendation to the university about their graduation honors. So when I say one of those honors designations before their names, please understand what that has entailed. Okay, so now, without further ado, here we go. Everybody ready? Oh, yes. I missed one more ado. Graduates, you are welcome, but not required, not obligated to go to the mic and say a few words after the picture part. It's up to you. Adele Alghezwi. Nolan Ailes. Graduating magna cum laude, Olivia Blevins. Graduating summa cum laude, Juliana Cessna.
Again, thank you, Mom and Dad, and my sister, and my partner, and Dave for being my advisor.
Junyu Chen.
Thank you, my family and my friends. Also, thank you, the APS department, the best department at CU. And also special thank you to my advisor, Jeremy Darling, and also Haley Roberts, Dr. Haley Roberts. Thank you.
Libby Cutler. Aluchi Emenyanu. Aiden Floyd. Stephen Gately. Cassandra Groulet.
I would like to thank my dad, my mom, my daughter Madeline, my nephew Aiden, and my best friend Sabrina and her son Jojo for being here to support me, and all the faculty and staff that have brought me through this. Thank you.
Henry Hitch. Ella Ho.
I'd like to especially thank my mom and my dad, my brother and my sister for being here, my best friend, all my friends, and my boyfriend for just supporting me throughout the years. I'd also like to give a really special thank you to the APS department. I've had a lot of struggles in my time here, but I've always felt very loved and supported, so thank you so much.
Stephen Christopoulos.
I want to thank my family, my brother, the APS department for putting up with me for all these years. I'm fully a better man after 5 years here. Thank you.
Quentin LaFemina.
You know, I was gonna poke fun at you guys and make a joke about space, but nah, you guys are out of this world.
James Loftus.
Thank you, Mom and Dad, and Andrew.
Emily Lookoff.
I'd like to thank my mom and my dad and my little brother for always standing behind me no matter what. And I'd like to thank all my professors, but especially Kevin France and Zach Berta Thompson for being endlessly patient. Thank you.
Graduating cum laude, Coda Lucas.
Definitely a lot of people to thank, but a special shout out to my dad and my family for coming out, and also my friends for supporting me all through these 4 years.
Molly Nearing. Nicholas Patterson.
I just want to thank my whole family, my parents, my brother, my grandparents, and all my wonderful professors who helped me look out into the stars. Thank you.
John Sembauer.
I just want to thank my family for being here today, and Go Buffs.
Chris Shorus.
First off, I just wanted to express my gratitude to the APS program, all the faculty members. Your guys' enthusiasm for the material does not go unnoticed, and it really makes our jobs as students a lot easier. And thanks to my family for putting up with my BS all these 2 decades. I love you guys.
Ben Stepanek.
This one's for my cat, Bordeaux.
Graduating cum laude, Harshini Sunil.
I just wanted to thank my family and friends for being here, as well as Zach Thompson, who is my advisor. I'm very grateful for all the connections I made here.
Daniel Shevchik.
Oh, that way. Okay. Thank you. I would like to thank my parents, my partner, and everyone that came out to visit me. It was a struggle over these past couple of years, but I made it, and thank you so much for you all being here, and also special thanks to Brian Fleming. Thank you.
Reese Trailer.
Just a quick thank you and I love you to my mom, my dad, and my brother. Go Buffs!
Graduating magna cum laude, Isabella Wise.
I would like to thank my family and just the APS department and faculty, and a special thanks to Paul Hain, my advisor.
Okay, did I miss anyone who's getting a bachelor's degree? 1 year I did that and it was a student who worked for me. Okay, good. In that case, everyone, let's please give all of our graduates receiving a bachelor's degree today a round of applause. Okay, I will now turn the program over to our Associate Chair for Graduate Education, Professor Steve Cranberry.
Okay, thank you, David. I'd now like to introduce the presentation of graduate degrees from the APS department. We have 10 new Doctors of Philosophy, 10 new PhD recipients to honor today. We'll continue to do that in alphabetical order. We'll also have both the student and their advisor come up to say a few words, and then we'll perform the ceremonial hooding of the PhD. They've all got their hoods, I think, ready to go. It's kind of interesting to know where these weird things come from. I actually learned that in medieval times, they were made of either fur or warm, some sort of fur or wool or something to keep the scholars warm as they toiled away in their chilly, scriptoriums or whatever they were. But now they have a happier, happier purpose, and we will perform that ceremony. So yes, we will start with Brian Alden, who is advised by Professor Jack Burns. Professor Burns couldn't be here today, unfortunately, but he has sent us something that he wanted to say, and I can read that for you. Professor Burns says, "Today we are here to celebrate the completion of Dr. Brian Alden's PhD dissertation entitled Investigating the Properties of Merging Galaxy Clusters with Radio Halos Relics Using X-ray Derived Pressure Maps." And Jack goes on to say, "It has been my privilege to serve as Brian's PhD advisor, his mentor, and his friend over the past 6 years. Brian is a combat veteran of the wars in Iraq and Afghanistan. This experience left Brian with some serious challenges to overcome while pursuing graduate studies in astrophysics. I am so proud of how Brian has met these obstacles and excelled in his classes and research with the love and support of his family and many friends. Brian's dissertation involved analysis of X-ray observations and numerical simulations of galaxy clusters, the largest bound systems in the universe. In the process of this research, Brian grew impressive talents for algorithm and large computer code development, which he plans to pursue professionally. We look forward to following Brian's career trajectory after launching him today, quote unquote, towards a bright future." We have Connor Weiss, who is advised by Dr. Yuri Chumre. And Connor's dissertation was called Across the Tacho-Klein Divide, Convection and Dynamo Action in M-Dwarf Stars.
So I was not Connor's thesis advisor, but I'd like to say a few words about Connor. He came to us in 2016 as a PhD student and is headed off now, but Professor Cranmer just read his thesis title, and Connor worked for Professor Yuri Tumre in our department. One of the two most senior members in our department, he just retired last week. And is still going to continue to be active in science. Professor Tumre does simulations of the interiors of stars. And Connor took on simulations of the interiors of a special kind of star, M stars. These are the most common kind of star in the Milky Way galaxy. About half of the stars in our galaxy are M-dwarf stars. And it just so happens, and now my own research is going to creep into my comments, it just so happens that this is also the most common kind of star around which we find planets as well. Connor has taught computers how to simulate what's happening inside these stars and explored what kind of magnetic field the stars create. I will let him tell you the rest in his comments, but Connor is headed off now to a job in data science, staying here locally. So Chief Niwat's curse seems to have captured you, and we are happy to keep you around. So with that, I will hood you, and then you can say a few words.
I don't have much more to say about my research, but I would like to thank my mom and sister and my wife and her parents all for being here. It means a lot to me to be able to share this with you. And I also would like to express my heartfelt gratitude to Yuri Tomre, although he could not be here today for a family obligation. The unfailing generosity that he has shown me throughout my time here, the value of it cannot be overstated. So just thank you, Yuri. Thank you all for being here.
Next, I'd like to call up Erin Kanji and her advisor, Michael Chaffett.
At its core, science is about telling stories. Astronomy has a proud tradition of telling stories that connect humans to their heroes and gods in the sky. Today, as astronomers, our job is to conjure images and make real the intangible planets, galaxies, black holes beyond the stars. And becoming a scientist requires mastering a lot of technical details. Erin's mastered a lot of technical details and argued a lot with computers over the course of her PhD. But the rarer and more valuable skill is being able to connect those details and those objects of study to us humans, to make the unknowable familiar. Science is storytelling, and Erin is a storyteller. She has a not-so-secret weapon in her arsenal, a secret advantage, which is that she did a bachelor's degree in theater, which, from which she learned that the great stories have to be told. But telling those stories is how we keep them and preserve them. And someone has to go out and find those stories to tell, to listen to the subtle details in the universe and collect them into a story that speaks to our hearts. And Erin is a scientist who does this. She never loses sight of the big picture. Whenever she's working on technical details or embedded deep in a calculation of atmospheric chemistry, she always connects it back up to the big picture. Her thesis is about photochemical modeling of deuterium to hydrogen fractionation in the atmosphere of Mars, from the troposphere to the thermosphere to the ionosphere. There's a lot of technical details, but the point is that she used computer models to turn this intangible stuff around us, this air that we breathe, into concrete knowledge of the history of Mars and of its potential to have supported life in the past. I could continue talking for an hour about all of the things that I'm proud of Erin for accomplishing and all of the things that I look forward to seeing her do in her career. She's going to be working as a postdoc here at LASP, so we get to continue our research relationship, and I'm really grateful to be able to continue to have this relationship in my life. Science is storytelling, and beyond all of the technical details, Erin's thesis is a story that she heard whispered on the winds of Mars. And I can't wait to see what other stories she tells over her career.
Now I say things right. Okay. Thanks, Mike. You can see why we go so well together, because Mike is also a very good storyteller. And I'm glad he brought that up, because I would like to make a promise to you all. I have spent 14 years in higher education getting various degrees, and I am no longer allowed to get any more, so please hold me to that. But it's been a really lovely place to do a PhD, and so I'll just say thank you to my family, who I believe are watching the live stream from Oregon and possibly Texas. Not sure if that link was sent around. And thanks to everyone in the APS department. I came here because I got the sense that it was a very supportive and positive place, and that I think really held out and made it a little bit easier to get through these last very difficult years. So Thanks to my classmates, the professors, everyone on my master's and PhD committees, and everyone in the brain and chaffing groups. And at LASP and on the Maven mission, there's a lot of you. Thank you to everyone. That's all.
So next up is Edwin Fernando Cruz Aguirre and his advisor, Kevin France.
Good afternoon, and thank you for coming. I'm Kevin France. I had the privilege of being Fernando's dissertation advisor. Fernando is one of the very rare astronomers who is an expert in both instrumentations, things we shoot into space to make rare and unusual experiments, as well as data analysis, understanding stars and how they influence planets. So Fernando did large research with the Hubble Space Telescope, but what I really want to focus on is his work as a sounding rocket student. So Fernando led the development and launch of a sounding rocket, which is this suborbital vehicle that's about 60 feet long and goes up into space for about 10 minutes to take data. So yeah, he's nervous about it, just talking about it. He's getting anxious, just like, because Fernando was at the controls, at what we call the attitude control system during the flight, actually steering the star into the aperture of the instrument. A very high profile video game. If you get it wrong, you don't get a second shot at it, but Fernando did amazing. He joins a long legacy of people who have done this now, going back all the way to James Van Allen at the start of the space age, through the Nobel Prize for the discovery of the X-ray background, and now developing technology for future missions that will allow us to find habitable planets. So it's been a great pleasure. Congratulations.
So I want to thank my mom and dad, my 3 sisters who are here, my fiance who's here, and to all of the other people that got this sounding rocket off the ground. It takes a lot of people to do this, many of which who are here throughout the country. So thank you all for your support. I did it.
Next up is Girish Vivuri, who was advised by both Zach Berta-Thompson and Sebastian Pineda.
Wow, what can I say about Dr. Du? I'm gonna go first, then Zach's gonna say a couple of things. Really, I think it's been a real privilege for me to be able to work with Girish. And over the past several years, just seeing both his insight as a scientist, as an educator, and really just a significant colleague, and really someone who's been pushing this field forward. And by this field, it's talking exoplanet science, stellar astrophysics, and his thesis title was The High Energy Emission of Low Mass Stars. And really, he sort of took on this topic and then just propelled it forward. And I think we were all, and as a scientific community, better off for his contributions, and really excited about what he's going to keep going on with in the future. So he's going to be a postdoctoral fellow at Vanderbilt. That's going to be really exciting. Yeah, and just been a real honor. So thank you, Girish.
And in the limited time here, I'm actually going to hand most of my words over to someone else. And this came from a book that Girish introduced me to as a huge lover of speculative fiction. He infected all of us. So the Voyager probes that are heading out into space, they're now about a light day away from Earth, have a golden record on them with a message from Earthlings to any aliens who might find them. The message from the UN Secretary General at the time was, we step out of the solar system into the universe, seeking only peace and friendship, to teach if we are called upon, to be taught if we are fortunate. And so serving as one of Grisha's PhD advisors, I think really, for me, has been a remarkable opportunity to teach occasionally when called upon, but mostly to be taught, because I have been so fortunate. And so that comes from a book called To Be Taught If Fortunate by Becky Chambers. And so I will paraphrase her and say, in honor of Girish and his thesis and his remarkable work, that Girish has found nothing you can sell. Girish has found nothing you can put into practical use. Girish has found no worlds that could be easily or ethically settled, would that end be desired. Girish has satisfied nothing but curiosity and gained nothing but knowledge. So thank you.
I have a lot of mixed up thoughts about intellectual heritage. Make a lot of choices about it. Not all of them are good ones. And we get a few more about what we pass down. I'm thankful for the choices that my advisors made. I'm thankful for the community I have found. And I hope we all make good choices, and I can consider APS a community in the future. Thank you.
Next up is Erica Egan, whose advisor was Brian Fleming, and Kevin France will also be coming up.
Hi, it's me again. Erica's, Dr. Egan's thesis advisor was Professor Brian Fleming. Brian can't be here today, so I have the honor of getting to do Erica's hooding. It's a special honor for me, though, because Erica spent most of her time working on the Colorado Ultraviolet Transit Experiment, which is NASA's first exoplanet studying small satellite, and she was the lead grad student on that. And yeah, that's good. I know, yeah. And it's cute. And then after this, she's moving on to a research scientist position at the Johns Hopkins University Applied Physics Lab. And I have some remarks from Brian that he asked me to read. I'm going to do it in my voice. Erica Egan is a very unique individual who I've had the pleasure to work with through all kinds of highs and lows for the past few years. She came to us with a non-traditional background, majoring in philosophy of all things, and she was certainly never shy about sharing her philosophies along the way. But that was an enriching experience for me, and I think I gained as much from her as I could possibly have imparted. She thinks up crazy ideas, most of which don't work, but some of which work brilliantly, and that's exactly what she needs to be a good scientist. She cares about policy and the leadership of our field, and the health of those who do the work in our field. I would not be surprised at all if in 20 years she's an administrator at NASA or some other high-profile, high-impact position. I would also not be surprised if she's working in a lab coming up with clever solutions to challenging problems, probably with magnets. Either way, I can't wait to watch her from afar as she sets out on the next stage of her career. I'm very proud of her, and I'm very grateful for the opportunity to have worked with her. Godspeed, Erica.
I was doing really good at not crying, and then Girish started crying, and I blame him. Grad school is really hard, and but there was so much more than that, and it took, like, space is a vacuum, but nothing that we experience is a vacuum, and science isn't done in a vacuum. It takes people, it takes time, it takes emotional support, and it takes a lot of people listening to me cry and a lot of people telling me things to build me up when I was struggling a lot. And a lot of that was my family. And so much of it was the APS community. And a lot of it was the research group too. I think that everything in a person's life that could have gone wrong probably went wrong during my grad school, which is unfortunate because mostly people complain about grad school being hard, but for me it was everything else. And I'm so grateful to Brian, who could solve none of my problems, but at least provided a very empathetic and sympathetic ear, which was helpful and all. It was enough. It was absolutely enough. And the same to Kevin and the rest of the research group. It was truly an honor and a privilege. And Seth mentioned at the beginning how astronomy is not looking up at the stars and wondering. It's a lot of code and it's a lot of writing and it's a lot of toiling away in a lab and figuring out what to do with a project that you can't solve. And I did a lot of that, but I would walk home late at night when the sun had already set and the stars were out and it was bright and it was a cool night, and I would look up at the stars and I would say, wow, lab work was hard, but do I just love the sky, and I can't wait to continue to share it with people and the wonder of the universe. And as I was walking home, you're slammed with the waves of starlight that hit you and the wonderful warm fuzzies of the friendship that I so badly wanted to share it all with. So thank you to everyone. Thank you to my family and Kevin and Brian and the lab and all of you for supporting all of us. So thank you.
Next up is Perry Ann Johnson, who is advised by Dr. Leslie Young and Dr. Larry Esposito.
I'll mention just a few bright moments of working with Perry as she got her graduate degree. Starting with the first weeks and months when she ate up research papers like other people eat potato chips. And then a glorious moment in a hallway at the Division of Planetary Science meeting when she and other colleagues crystallized the idea of Perry's Paleo-Pluto, which turned into her thesis, which was on studying Pluto and its climate from very short time scales, merely hundreds and millions of years, all the way back to the birth of the solar system. And other bright moments is every time we met, it was a highlight. Watching her grow, her other advisor, Larry Esposito, was an advisor's advisor. He said, my job is to make her know more than I do, and that happened very quickly. It was wonderful to see. So Perry, as you go on to your postdoc and continue in your career, wherever it leads you, my hope is that you study interesting problems with wonderful people and change the world.
So first of all, I want to thank my amazing advisor, Leslie, who taught me everything I know about Pluto, but more importantly than that, she taught me everything I know about how to be a good, effective scientist. She taught me the value in being the kindest or the most helpful person in the room, rather than needing to be the smartest person in the room. I also would like to thank all of my wonderful family who's here today, including my little niece in the back there. I'm so thankful for you guys for encouraging me in my my science and my nerdy career choices for the past 23 years of schooling. And I also want to thank everyone in the APS community and also at my SWERI community, and especially my best friends Alicia, who's here in the room, and Raven, who's watching online. So thank you all.
Next up is Jenny Payne and her advisor, Jeremy Darling.
There's a notion in cosmology called the Copernican principle, or the cosmological principle, or simply the mediocrity principle. It says in effect that we're not special. I know we've heard a lot of special things today. What this principle says is we don't occupy a special place or time, a reference frame in the universe. This special place and time notwithstanding, of course. Part of Jenny's work tested this notion. Her dissertation is titled Probing the Dynamic Universe with the Motions of Stars and Galaxies. So let's start with the galaxies. Jenny laid the foundation to test our specialness by measuring the apparent motions of galaxies across the sky, which move so slowly that we have historically assumed they don't move at all. What we will someday see, thanks to Jenny's pioneering work, are galaxies streaming across the sky as we zoom through the universe. She also asked, are there any special directions in the universe? The answer is no, so far. Now the stars. Jenny spent years tracking the motions of stars orbiting a massive black hole in the center of our galaxy you heard about earlier today. But these are not just any stars. These are giant stars that shoot out microwave laser beams. Yes, space lasers. Jenny reached new levels of precision in tracking the motions of these stars. This work may someday tell us about the hair on black holes. So Jenny, you have persevered through difficult times and solved many difficult problems. You put up with my repeated backtracking to check the fundamentals, again, and listened patiently to my silly parables. You did new and important work and made amazing new discoveries. So congratulations, Dr. Payne.
I wanted to start off by saying thank you to Jeremy for being a wonderful advisor and just incredibly supportive for the last almost 7 years. And then I also just want to say thank you to my family for all of their support, especially my husband. This time last year, my daughter was less than 2 months old, and I did not think I was going to get this degree. I'm going to cry now. And I really would not have without a lot of support for my family, my husband, and also the APS community. So thank you, everyone.
Next up is Haley Roberts, who also was advised by Professor Darling.
So you get to listen to another little parable. Not very long ago, it was thought that galaxies were island universes that didn't interact or collide. We've since learned that galaxies interact in all kinds of ways, and astronomers, of course, have come up with creatively violent names for these interactions. They strangle, they cannibalize, they harass, they collide, and they merge. It's the most massive colliding and merging galaxies that Haley has been studying. Haley's dissertation is titled The Past, Present, and Groundbreaking Future of OH Megamajors. Contrary to the title, Haley also broke significant new ground in the present. OH megamajors are microwave lasers in space, yes, space lasers again, created by the hydroxyl molecule, OH, which is just broken water. These masers are millions to billions of times stronger than the ones we see in our galaxy. And it takes the collision of two massive galaxies to create the conditions for these rare events. Haley discovered new OH megamajors, and she was part of a team that found the most distant one yet. Light from this most distant maser, named Nkalakatha, EC Zulu for Big Boss, has been traveling for 5 billion years. She also predicts an OH megamaser bonanza in the years to come. When Haley approached me about a research project, she told me that she wanted to use machine learning. I told her I don't know anything about machine learning. So So she went and learned about machine learning herself and then taught all of us how machine learning works. She wanted to use a telescope in Spain. I told her I had never used that telescope in person. So she went to Spain. She cold called large projects and they invited her in and put her in charge of sub-projects. In a sense, Haley found her wings and left the research nest early. But lucky for us, she stuck around to show us new ways of flying. I'm just so happy to have Haley as a colleague. Congratulations, Dr. Roberts, you did it.
Thank you. First of all, thank you to my advisor, Jeremy Darling. If you can tell by his incredibly kind words, he is a phenomenal person to have guiding you through this crazy, crazy field and degree. I just, I've had a genuine blast doing my research, and I think that's a privilege granted from phenomenal advising. I also want to thank my family who is watching online. Thank you so much for everything you've done for me, and my partner who is here, and my friends who are here, and just what a great community to have spent my time in. I'm so thankful for all of you.
And lastly, I'd like to call up Amanda White, whose advisor was Dr. David Harrington at the National Solar Observatory. Unfortunately, Dr. Harrington couldn't be here, but I can say a few words as a member of Amanda's thesis committee. I've known Amanda since she started here in 2016. Amanda has started on a journey of learning about the mirrors that are so important to telescopes, specifically telescopes that look at the sun. Right? So the sun's light focused on these small mirrors. You need to know a lot about the properties of those mirrors to understand what kind of astronomy results come out of that. So Amanda has been in the laboratory and studying on the computer the properties of these mirrors. So in the process of being here, Amanda has been awarded the 3-year George Ellery Hale Graduate Fellowship. She also received the Chance Irick Cook Endowed Fellowship in Astrophysical and Planetary Sciences. And she also represented the department in the CU 3-minute thesis research competition, which involves a ton more work than just 3 minutes. and yeah, so I just wanted to congratulate Amanda.
Thank you, Steve. And I'd like to thank also Dave and Zach and Nils and everyone who has made me stay. And I'd also like to thank Beaky, my husband, for literally picking me up off the floor multiple times. Thank you.
So that concludes our graduate degrees. Let's give the 10 PhDs a round of applause. I can now turn it back over to Professor Hornstein.
So once again, I'd like to thank the entire graduate and undergraduate class of 2023.
As that concludes our ceremony, a few final housekeeping announcements. As we leave, please let the faculty and the graduates exit first, and then feel free to follow us out directly to the front of the planetarium, where we will take a few celebration photos. Parents, family, feel free to come join us and take your own as well. We will have the department ones. After the photos, we'll return back inside the lobby for the reception. Students, if you'd like to show your family and friends around Summer Spouse Observatory, it will be open from now until about 4 p.m. Feel free to take folks up there to show them around. And with that, I'd like to thank you all for coming, and congratulations again to the class of 2023.